Okay, so we're going to continue with example number 5, where we have the function g of t equal to negative 7 over 2t minus 3 squared. So um, again, we want to take the derivative of this function. What I want to do to start here is, again, you can take this derivative using quotient rule, but I think it's going to be easiest to take this derivative using power rule if we rewrite it as negative 7 times the quantity 2t minus 3 raised to the negative 2 power. Okay, so when we differentiate this function, g prime of t, we can pull negative 7 out front. And then again, because we have the quantity 2t minus 3 to the negative 2 power, that is a composite function. We're going to differentiate using chain rule. So my outer function in the composition is t to the negative 2 power, whose derivative is negative 2 times something to the negative 3rd power. We're going to evaluate that at the inner function, 2t minus 3. And then we're going to multiply that by the derivative of the inner function, which is 2. Okay, so I just want to combine this now into a single fraction. So negative 7 times negative 2 is 14, times 2 is 28. And then 2t minus 3 to the negative 3rd power, that's going to move the quantity 2t minus 3 cubed into our denominator. Okay, so that right there is our derivative simplified completely. Okay, on to number 6. So for number 6, we have the function f of x equal to x divided by the cube root of x squared plus 4. So again, we're going to take the derivative of this function. We have to use quotient rule to start because f of x is the quotient of two functions. Okay, so that's going to be low cube root of x squared plus 4. D high, the derivative of the top function is 1, minus the quantity high, d low. So if we're going to take the derivative of the bottom function is a composite function. It is x squared plus 4 raised to the 1/3 power. Okay, so that's a composite function. We have to use chain rule to differentiate. So the outer function in the composition is x to the 1/3 power, whose derivative is 1/3 times something to the negative 2/3 power. We're going to evaluate that at our inner function, x squared plus 4. And then we're going to multiply that by the derivative of the inner function, which is 2x. Okay, so that's low d high minus high d low all over low low, which is going to become the cube root of x squared plus 4 quantity squared. Okay, so I'm going to simplify this by rewriting my numerator back in the form of a radical, and then that quantity in the brackets I want to write in fraction form. Okay, so this is going to give me the cube root of x squared plus 4 minus, okay, so when I multiply all that stuff out, in what I'm going to be left with in the numerator is 2x squared. And then in my denominator, I'm going to have 3 times x squared plus 4 to the negative 2/3 power. I'm going to put x squared plus 4 to the 2/3 power in my denominator. And when I rewrite that in radical form, that's going to be 3 times the cube root of x squared plus 4 quantity squared over On bottom, we have the cube root of x squared plus 4 quantity squared. Okay, so we want to simplify this. So again, we have a complex rational expression here. We want to multiply the numerator and denominator by our common denominator of the smaller fraction, okay, which is going to be 3 times the cube root of x squared plus 4 quantity squared. So we're going to multiply the top and bottom by that. So we have 3 times the cube root of x squared plus 4 quantity squared. Okay, so when I distribute that in the numerator, we get f prime of x equal to, so the cube root of x squared plus 4 times 3 times the cube root of x squared plus 4 squared is going to give me 3 times the cube root of x squared plus 4 quantity cubed. And the cube root and cube wind up canceling one another out, so that just becomes x squared plus 4. Okay, so we have 3 times the quantity x squared plus 4. Okay, when I multiply it by the next quantity in the numerator, the 3 times the cube root of x squared plus 4 quantity squared cancels. Okay, so that just leaves us with minus 2x squared. And then our denominator here becomes 3 times the cube root of x squared plus 4 raised to the 4th power. Okay, so we're almost done. In the numerator, when I distribute the 3, we're going to get 3x squared plus 12 minus 2x squared over 3 times the cube root of x squared plus 4 raised to the 4th power. And then when I combine like terms, we get x squared plus 12 over 3 times the cube root of x squared plus 4 raised to the 4th power. Okay, and that right there is going to be the derivative of that function. Okay, so I'm going to have you guys do number 7. Okay, so pause the video while you work out the derivative to number 7, and then I will come on and work this one out for you as well. Okay, so when we differentiate number 7, again, we are going to use quotient rule to start. So that is low d high, the derivative of the top function is 1, minus high d low. So our bottom function is x to the 4th plus 4 raised to the 1/2 power. Okay, so the derivative of that, again, my outer function is x to the 1/2 power, whose derivative is 1/2 something to the negative 1/2 power. We're going to evaluate that at the inner function, x to the 4th plus 4, and then multiply that by the derivative of the inner function, which is 4x cubed. Okay, so that's low d high minus high d low all over low low, which is rad x to the 4th plus 4 quantity squared. And x to the 4th plus 4, when I take the square root of that and square it, the square root and the square are going to cancel one another out. Okay, so that just leaves me with x to the 4th power plus 4. Okay, so let's go and rewrite that numerator back in fraction and radical form. So rad x to the fourth plus 4 times 1 is rad x to the fourth power plus 4. Minus, so I can cancel that factor of 1/2 with a factor of 2 here. So when I take a look at what's left in the numerator, we have x times 2x cubed, which is 2x to the fourth power, divided by, and then x to the fourth plus 4 to the negative 1/2 power is going to put rad x to the fourth plus 4 in my denominator. And then we are dividing that by x to the fourth power plus 4. Okay, so just like in the previous problem, we have a complex rational expression. We want to simplify this, multiplying the numerator and denominator by the common denominator of our smaller fraction, which is rad x to the fourth power plus 4. Okay, so when we multiply that in the numerator, we have rad x to the fourth power plus 4 times rad x to the fourth power plus 4. That is x to the fourth power plus 4. Minus, when I multiply rad x to the fourth power plus 4 times the fraction, the rad x to the fourth power plus 4 is canceled. So that's minus 2x to the fourth power. And then on bottom, this right here is x to the fourth plus 4 to the first power. This is x to the fourth plus 4 to the 1/2 power. And when we have two exponents that share the same base, when we multiply them, we're going to add their powers. So the power of 1 plus the power of 1/2 is going to make our denominator x to the fourth plus 4 raised to the 3/2 power. Okay, so we just want to combine like terms in the numerator. So we get y prime equal to 4 minus x to the fourth power over x to the fourth plus 4 raised to the 3/2 power. And then we just want to go through and simplify the numerator. So that numerator is the difference of two squares. It's going to factor to 2 plus x squared times 2 minus x squared. The denominator is going to be x to the fourth plus 4 raised to the 3/2 power. And we still have a difference of two squares. In our numerator, I can rewrite 2 minus x squared as like rad 2 squared minus x squared. So I can also factor that as the difference of two squares. So this is going to become 2 plus x squared times rad 2 plus x times rad 2 minus x all over x to the fourth plus 4 raised to the 3/2 power. Okay, and that right there is your derivative simplified completely. Okay, with number 8. Again, I want you to try number 8 on your own. So for 8, we have g of x equal to the quantity 3x squared minus 2 over 2x plus 3 squared. Wyatt, no. Son, Okay, sorry about that. So with this one, 8's a little bit different in that when we look at our function here, we have to perform chain rule first because we have a composite function that we are looking at here. So when we take the derivative of this, our outermost function in the composition is x squared, whose derivative is 2x. We're going to evaluate that at the inner function. 3x squared minus 2 over 2x plus 3. And then we have to multiply that by the derivative of the inner function. So if we're going to take the derivative of the inner function, we have to use quotient rule to differentiate that inner function. Okay, so quotient rule again is low, 2x plus 3, d high, the derivative of the top function is 6x, minus high, 3x squared minus 2, d low, the derivative of the bottom function is 2, all over low, which is 2x plus 3 quantity squared. Okay, so I'm going to rewrite this g prime here as 2 times 3x squared minus 2 over 2x plus 3. And then I'm going to start cleaning up the quotient over to the right that we use quotient rule on. Okay, so when I distribute, we're going to get 12x squared plus 18x. And then I'm going to combine two steps in one. So I'm going to distribute 2 across both terms, and then I'm going to distribute the negative across that result. So whenever I do that, I'm going to get minus 6x squared plus 4 all over 2x plus 3 quantity squared. Okay, so g prime of x is 2 times 3x squared minus 2 over 2x plus 3 times, when I combine like terms in the numerator, we're going to get 6x squared plus 18x plus 4 all over 2x plus 3 squared. And then I'm going to combine these two fractions here. So before I do that, when I look at this numerator right here, I can factor a 2 out from that numerator. So that numerator I can rewrite as 2 times the quantity 3x squared plus 9x plus 2. Okay, so when I multiply across in the numerator, I'm going to take this 2 times this 2, and that's going to give me 4 times 3x squared minus 2 times 3x squared plus 9x plus 2 all over 2x plus 3 times 2x plus 3 squared gives me 2x plus 3 cubed. And then the last step, like if I want to factor this completely, when I look at this quantity right here, 3x squared minus 2, I can actually think of that as the difference of two squares. I can rewrite that as rad 3 times x quantity squared minus rad 2 quantity squared. So I can factor that as the difference of two squares. G prime of x would be equal to 4 times rad 3 times x plus rad 2 times rad 3 times x minus rad 2. I cannot factor the quadratic 3x squared plus 9x plus 2, so we're going to leave it as so. And then my denominator is 2x plus 3 quantity cubed. Okay, so that right there is that derivative taken and simplified completely. So problem number 9 is a little bit different because when we look here, we have like multiple compositions in our function. Okay, so if we want to differentiate this, we want to think of like peeling away like one layer at a time. So we have 2 plus the quantity x squared plus 1 raised to the 4th power. And then we're taking that whole quantity and cubing it. So when we look at that function, the outermost function in the entire composition is x cubed. So if we want to take the derivative of x cubed, that is 3 times something squared. Okay, we're going to evaluate that at our inner function, which is 2 plus x squared plus 1 raised to the 4th power. And then we're going to multiply that by the derivative of the inner function. So my inner function here is that entire highlighted function. Okay, so when I take the derivative of that, the derivative of 2 is 0 plus, if I want to take the derivative of x squared plus 1 to the 4th power, I have to use chain rule on that because that is a composite function. Okay, so the outer function in that composition is x to the 4th, whose derivative is 4 times something cubed. We're going to evaluate that at the inner function, x squared plus 1. And then we're going to multiply that result by the derivative of the inner function, which is 2x. Okay, so that 0 plus, like I can go ahead and get rid of that. And then I just want to go through and clean up our factors here. So I can take this factor of 4, that factor of 2x, pull both of those out front, and multiply that by 3. So that's going to give me 8x times 3, which is 24x. And then we're going to multiply that by 2 plus the quantity x squared plus 1 to the 4th power squared. And then our leftover factor is x squared plus 1 cubed. Okay, and that right there is our derivative taken and then simplified completely. Okay, so you guys can go ahead and move on to video number 3.